Have you ever wondered how the birds know where to fly? After all, they don't have a GPS, a map, or any signs to guide them in the right direction. Although it might surprise you, the answer lies inside their eyes. Firstly, the birds do have a GPS, sort of. It's called the magnetic field and it's all around us. However, for a long time, scientists could not figure out how exactly the magnetic field would affect birds since it is very, very weak, much weaker than what is needed to break bonds. Imagine this like trying to cut down a tree by throwing a paperclip at it. It would not have a big effect. Now, imagine that the tree was already partway chopped and nearly falling over. Could the paperclip just provide the final impulse? Probably yes. The tree, in our case, is the radical pair mechanism. The radical pair mechanism involves, as the name suggests, radicals, atoms that contain at least one unpaired electron. Electrons have this weird property called spin. Either they're spin up or spin down, and two paired electrons always have the opposite spin. Now, when we separate the pair, sometimes the spin of one electron flips. Other times it doesn't, and this alone would not be enough. But due to hyperfine interactions in the nucleus, the pair enters a superposition, being both in a singlet state and a triplet state, both at the same time. Picture it like throwing a coin in the air and watching it spin. Is it heads or tails? Well, until it falls into your hand and collapses, it's sort of both? It is such an unstable state that even something as weak as the magnetic field can affect the outcome. So, knowing all this, is there a place in the bird where radical pairs are formed? Actually, yes. When light reaches a bird's eye, thanks to a protein called cryptochrome, the birds can sense the magnetic field and get back home safely. On that note, can you use your magical magnetoreception superpowers to get us out of here? No. Well, this is gonna be a long night.